This is the second video for UMTM Calculus 2, Class 2, and in the previous video we reminded ourselves of some definitions, domain, codomain, range, etc., and we ended with the discussion of what a graph is, and I showed an example of 2D, and in our previous studies we have created 3D graphs, but we've kind of stuck to our previous experiences and some well-defined forms. For example, in this first equation here, we have x squared plus y squared plus z squared is equal to 1, and from our previous studies we know that this is really just the unit sphere. And that's fine, but we want to know, okay, well, not everything's going to be a nice, well-defined figure that we've seen before, so, well, what if we have something like z is equal to f of x, y, what do we do? How do we graph that? And so, well, what we can do is we just recognize that this is really just a height. Oops, and I erased that. A height. And then x and y, that determines where we are on a plane. So maybe what we could do, and here's an idea, okay, an idea, can we fix a height? Okay, and by that I mean let z equal to a number, and then find, and then look at what x and y yield. Okay, because then it's just an equation in x and y, and we can certainly work with that as we have in our previous studies. Okay, so let's try that idea here. So we want to sketch the graph of z is equal to f of xy, okay, and it doesn't much matter which one you use, is equal to x, the square root of x squared plus y squared. I think we saw this in the last video, or a variation thereof. Well, let's fix a height. Okay, so let's try that idea. Z is equal to 0. Okay, well, if I do that, then I get 0 is equal to the square root of x squared plus y squared. And simplifying that, I get 0 is equal to x squared plus y squared. And, okay, the only way to get the sum of two positive numbers to be 0 is if they're both 0. So this gives me the point 0, 0, 0, or the 0 vector in 3 dimensions. Okay, well, that isn't too exciting. Let's continue on and see if this method is going to produce anything. Z is equal to 1. Okay, and here I get 1 is equal to, try that again. 1 is equal to the square root of x squared plus y squared. Okay, and then squaring both sides, you get 1 is equal to x squared plus y squared. Oh, and this is just a circle centered at the origin with radius 1. Oh, that's useful. Okay, and z is equal to 2. I'm just going to do a bunch of these and see what happens. And again, going faster through the algebra, 4 is equal to x squared plus y squared. All right, and this is going to be a circle of radius 2. Okay, and z is equal to 3. I think you might be able to guess what happens. You get a circle of radius, with radius 3. Okay, etc., etc. So, if I were to put this all together, and I'm going to draw in 3 dimensions, and you all know that I'm the best artist on this planet. Alright, so I have x, y, and z, and just a reminder, always label your axes, because at this level we can change the axes at various points. Okay, so just putting this all on here, I have the origin, or the 0 vector, and then I have, and this is just a sketch so it doesn't have to be precise, so I have a circle of radius 1, followed by a circle of radius 2, followed by a circle of radius 3. Okay, and if I connect the dots, not really, if I connect the dots or connect the figures that I found, okay, kind of like so. Okay, and imagine this spinning around the entire outside. What I end up with is a single cone. All right. So, and this idea, really what I did, I think we've seen this idea before back when we were way back in Calc 1 when we were learning integration and doing like volumes of revolution and whatnot. This idea of picking values for z is really just cross sections. Okay, we do several of these and try to get a general idea of what's going on and then put it all together and name the shape when possible. And that's really the general method we're going to employ when we graph in 3 dimensions.